Everybody who just joined us, let's give a warm welcome to Kaushal and what's new in Gluster.
Yep. Thanks everyone. Good morning. So I'm Kaushal. I'm a maintainer of the Gluster in the GlusterOffice project where I maintain. Sorry. Okay. I'm Kaushal. I'm a maintainer in the GlusterOffice project. Sorry, I switched it on. Yeah. I'm a maintainer in the GlusterOffice project where I maintain the distributed management daemon for GlusterOffice called GlusterD. So today I'll be talking about our new upcoming release, Gluster 4.0. This is one of the biggest releases we'll be this is a major release that we are doing coming up soon. So in today's agenda, I'll give a quick intro to Gluster to people who don't know what Gluster is, and I'll follow that up with describing what Gluster 4.0 brings new. Okay, so what is Gluster? Gluster is a software-defined network storage system. It provides users with a distributed, replicated, or erasure-coded storage. So it's purely software-driven, and one of the salient features of Gluster is that we don't have a centralized metadata server. We are purely distributed and work without any central metadata servers. We work on commodity hardware. That means we don't need specialized storage appliances to run Gluster. We run on normal off-the-shelf x86 servers, and we are scale out, as in to grow a Gluster storage, you add more servers when you need. Gluster provides users with a POSIX compatible file system. So Gluster provides a native Fuse client, which is POSIX compatible, and so applications can be pointed to the GlusterOffice mount, and you can reasonably expect them to work without any problems. So, and in addition to the native GlusterOffice mount, GlusterOffice protocol mounts, we provide access via standardized protocols like NFS and SMB via integration with other projects like NFS Ganesha and Samba. Okay, so some terms to help understand things later in this in the presentation. So yeah, in GlusterOffice terminology, we have peers or nodes or servers. I use them interchangeably. So a GlusterOffice server is a computer which contains GlusterOffice server packages installed. So lots of Linux distributions have GlusterOffice packaged installed on them in their default repositories, and you can install those packages onto your server, and that becomes a GlusterOffice server for you. We pool these GlusterOffice servers together to form a trusted storage pool. This is what we call the GlusterOffice cluster. And we have clients. These are the people who access the GlusterOffice storage using the native protocol. So this picture sort of gives an overview of the trusted storage pool. So we have servers with GlusterOffice installed on it. They form a trusted storage pool, and we have clients outside the trusted storage pool who talk to GlusterOffice servers. So we have the native Fuse client, which talks directly, and we have the other external applications which use our GF API or the GlusterOffice API, so that we can export GlusterOffice volumes using projects like Samba and Ganesha. And we also integrate with QEMU to provide direct access to GlusterOffice storage for QEMU and for QEMU. So there's some more GlusterOffice terms. So we keep talking about bricks in GlusterOffice. So a brick in GlusterOffice terms is the smallest unit of storage in GlusterOffice. So basically, when we talk about bricks, there are two things. There is the brick directory and the brick process. It's a combination of these two. A brick directory is an empty directory on your server, GlusterOffice server. In majority of the deployments or in general deployment, this empty directory is the mount point of one of your disks on the server. And a brick process is something that exports that directory out to clients. And then we have a volume. A volume is a logical collection of these bricks to provide you with the distributed, replicated, redundant storage, right? So, yeah, so we have servers with disks on them or mount points on them, so we can combine different bricks to get volumes that you want with different characteristics that you want. And GlusterFS makes it really easy to do this. And some more. And GlusterFS is built on, built using, the concept of translators. So in GlusterFS, all the file system features that you hear of are built using modular bits of code called translators. So each of these translator performs just one action. So it provides one feature of the GlusterFS. So there is a replication translator which just performs replication. There is a distribute translator which has the distribute logic. There are performance translators which do things like read ahead, write behind. There are translators that do caching and stuff like that. So there are translators, and we arrange these translators in a volume graph to give you a volume with the features that we asked. Okay, so all of these translators will be arranged. So each of the blue, the blue boxes here is a translator. So we have a graph for the client side, we have a graph for the server side, for the brick process, and each of them is a translator implementing a separate feature. So we have the fuse translator, which implements the which talks with the kernel fuse module. We have other translators here. We have a distribute translator here. We have a translator that talks over the network, that talks the GlusterFS network protocol. Similarly, we have translators on the other side. Finally we have like the POSIX translator, which actually writes the underlying file system. So yeah, and this is a volume graph that we have. So this is a very simple graph without any branches, without any distribution. But in actuality, you'd have branches starting out from the distribute translator, so that you have multiple bricks, you have replication and all available. So how do you use Gluster? So using Gluster is really simple. Once you have installed GlusterFS server packages on your servers, you form the trusted storage pool by using the peer probe command. So this is where you let each of the GlusterFS server know of each other. So you form a trusted storage pool. Then you create a volume using the Gluster volume create command. So to create a volume, you give a name, you specify the redundancy that you want, or if you want erasure coded, you can specify the erasure coded parameters. Then you give a list of bricks that you want to use for this volume. And then you start the volume, and now once the volume is started from the clients, you can go ahead and mount with just a simple mount command. So you have just basically 4 steps to create a usable Gluster volume. Okay. So now, before going on to Gluster 4.0, a little bit of history, and I'll also talk about where we are right now. So okay, so GlusterFS started as an attempt to create a Linux distribution to create a supercomputer out of commodity hardware. So the founder of GlusterFS, Gluster, worked in a US National Laboratory where they worked on supercomputers. They thought they could do the same using software. So Gluster started as such a project, and GlusterFS was part of this larger project to provide the storage for the supercomputer. So GlusterFS V1 was a part of the bigger project. By the time V2 came out, sometime in mid 2000s, GlusterFS storage, GlusterFS had taken more importance in the Gluster project, and by V3, GlusterFS, which was released late 2000s, GlusterFS had become the primary project for Gluster, for the Gluster community. So let's talk a little bit of Gluster 3.x. This is a really important release for us. Gluster 3.0 was released in December 2009. So 9 years back. This was the release in which our protocol was defined. Our network protocol that we speak till now was defined. This is important for us for 4.0. And Gluster 3.1 was released in October 2010. This added Gluster D, the distributed management framework, which makes Gluster really simple to use, which allows those simple 4 commands that we saw to work, right? So this also brought along things like a native NFS server and other stuff. But yeah, the big thing with Gluster 3.1 was Gluster D. And we had a lot more releases after that in the 3.12, 3.x series. We brought in lots of features, erasure coding. We brought in features that are that provide you with like a NAS appliance, features like snapshots. Then we brought in things like GF API, which allows us to integrate with external projects better, and that allows us to integrate with Ganesha and Samba to provide better NFS and better SMB access. We recently started integrating much more with the container world, with Kubernetes and OpenShift in particular. So we have a project called Hekiti, which provides a it provides a layer in between GlusterFS. It provides a REST API for managing GlusterFS. So it provides users with a single call to create a GlusterFS volume. So you don't need to specify the bricks and stuff there for Hekiti. You just say, I want a volume of certain size. Hekiti will give you a GlusterFS volume of certain size. So these are like the major features that GlusterFS gained over the releases. And right now we are at GlusterFS release 3.13. This was released in December 2017. It's the latest release. It's a short-term maintenance release. It's supposed to reach end of life next month, but yeah. And now let's go on to the future, to Gluster 4.0. So Gluster 4.0 is going to be a major release, like one of the biggest releases since 3.0 for us. It's scheduled right now for February, later this month. We have branched out like 2 weeks back, and yeah, will be the release should happen soon. This is again a short-term release because this is the initial release of this project, of this branch. We know there'll be some bugs, and there are some few things that are missing that will make it not recommended to use for really long-term production deployments right away. And it is going to drop support for older distributions by default. So CentOS 6 and EL6 won't be supported, and the relative Ubuntu or Debian distributions are also going to be dropped from the community side. So what does Gluster 4.0 bring? So Gluster 4.0 brings protocol changes. This is like one of the first time that we're making proper version protocol changes since 3.0, and it's bringing a new management layer for Gluster. So these two are the big changes for us. In addition to that, there are a few smaller features like we have instrumented the code a lot more so that we can get metrics to do performance analysis and other stuff better in the file system path. We have done some changes internally with the algorithms that we use internally for hashing for certain stuff to make sure that Gluster can run on FIPS compliant systems. Gluster won't be FIPS compliant. It's not FIPS validated, but Gluster can run on a FIPS system. So there are a lot of performance enhancements, I guess, with particularly with respect to like directory operations, and there are a lot more performance enhancements in the queue. So if people attended the we had a talk yesterday in the performance track in the main tracks, where we spoke a lot more about what we're doing with performance for Gluster. So yeah, so those were just the 4.0 features, but we have a lot more features coming on. We have been talking about a lot of other features for Gluster 4.0 release, but these are not landing in 4.0. They will come somewhere down the 4.x release line. So we have this thing called Rio. This is a new distribution algorithm that should help with distributing large directories or directories with large entries much better. There is journal-based replication, which tries to push replication to the server side and makes improvements there, performance improvements as well. There is this thing called GF proxy. Some of these features are already available but not fully baked right away. But there is this thing called GF proxy, which tries to provide users with a lightweight client. So right now in GlusterFS, clients have all the intelligence and they're pretty heavy. They take care of doing the distribution. Clients have the distribution intelligence. Clients have the replication intelligence, etc. So GF proxy tries to provide with a lightweight client and move some of the intelligence out to the server itself. There's this thing called hero replication, which should allow replication, active replication across data centers. We already have geo replication, which does replication across data centers, but it's asynchronous and it's in a master slave mode, where you can write only to one. You can write only on the master. We have a feature called Arbiter, which tries to solve some split brain issues by replicating just the metadata like 3 times instead of the full metadata and data 3 times to make better usage of storage. There is a feature, an improvement to that coming called Thin Arbiter, which tries to make Arbiter even better. There's this thing called +1 scaling, which should allow users who are using replicated or erasure coded volumes to scale by growing adding one extra server. So right now with erasure coded or replicated volumes, if you want to grow your volume, you need to add the replica number of servers or the EC parameters number of servers to grow your volume. So that doesn't always it is not always helpful. And along with that, we also want to bring more automated management features to help administrators perform like the day 2 operations much better, day 1 and day 2. So again, like we talked about Hecate, right? So we want to pull in some of Hecate features into the GlusterFS itself to provide say automated volume creation where you don't need to specify breaks. And then we also want to do things like provide day 2 operation support for doing things like replacing failed breaks, replacing failed servers automatically and stuff like that, doing migration, doing healing, all in a better, much more automated way. Okay, so now let's talk about Gluster 4.0 in particular. So as I mentioned, protocol changes is one of the most important, biggest things in Gluster 4.0 that's happening in Gluster 4.0, and one of the things that's driving us to move up a version number. So what this means is that we have a new on-wire RPC version. So we had the RPC set at Gluster 3.0. We did changes to the RPC, but it wasn't really good, done in a really nice way, but still technically a Gluster 3.0 client should be able to work with a Gluster 3.13 client server. But now we are bringing in a new on-wire RPC that breaks this. What this means is that we have improved upon our on-wire RPC structures. So Gluster uses Sun RPC on-wire with XDR data encoding. So with the protocol changes, we have we have improved upon the structures we used, request response structures we use to add in more members for explicit members to the structs. So and we also made sure we improved upon the on-wire representation of our dictionary data structure. So all GlusterFS on-wire operations RPCs contain a member called xdata. It's a dictionary data structure. It can contain arbitrary data, so arbitrary key value pairs, so where the value can be of any data. So what had happened since the 3.0 release, during the 3.0 release, was that we started putting more and more things into the xdata structure, xdata member, as we started implementing more features. So that was one problem, because it was in a dictionary and we always had to encode and decode from the dictionary again, do double encode decodes when you send information across the wire. So once for the XDR struct itself, one for the dictionary. And the other problem was the dictionary itself wasn't really well built. So what happened was all the values that you added into the dictionary, to send them over the wire, they were encoded as strings, and again, when decoding, they were read back from strings and tried to be converted to their original format, data type. So that wasn't really good. So there is a new dictionary data structure for on-wire, new dictionary representation for on-wire, which avoids this. So that makes dictionaries also more performant. So, but even though we are doing these protocol changes, we still have the older RPC version available. This should be there for quite some time to allow older clients to work with Gluster 4.0. It may be deprecated sometime in the future. I'm not sure of exactly when we'll do this. But yeah, these are the protocol changes. And we also have Gluster D2, which changes a lot internally with how Gluster is managed. But to the end users, it should remain mostly transparent. It should be similar to what you already experienced. So Gluster D2 is the new management system for Gluster 4.0. Gluster D2 is not backwards compatible with GD1 or classic Gluster D. This means that we can't have a hybrid 3.x and a 4.x cluster. Okay. So, but the thing is, Gluster D1 is backwards compatible with the clients. So clients can still talk to clients, as in the file system clients can still talk to Gluster D1, Gluster D2, and perform their mounts. So that's still there. Gluster D2 is a from scratch rewrite, and it's written in Golang. It aims to scale much better than Gluster D1. It aims to improve our integration stories, integration with external projects, and integration of GlusterFS features themselves to to the Gluster management framework. And it also aims to reduce the maintenance effort required going forward to maintain the management framework. So what does Gluster D2 bring? So Gluster D2 brings a more, universal API for management. So in Gluster D1, we just had a CLI. There was no other API available to you to manage Gluster. So Gluster D2 gets a REST/HTTP API, REST-like. It's not pure REST, but it's an HTTP API. This allows GlusterFS integration with other projects easily, as almost all languages have really good integration with HTTP and JSON. So there is a new CLI tool which talks to this REST API. The new CLI tool, though it's new, will still retain most of the syntax of the existing tool. So there is not a lot to relearn. And internally in Gluster D2, we have done a lot more changes to make Gluster D2 itself more flexible and more pluggable for future enhancements. So we have improvements to our internal transaction engine. So the transaction engine is the thing that we use to perform operations across the cluster across the storage pool. We have a better implementation of Volgen. Volgen is the piece of code inside Gluster D that builds the translator graphs, the volume graphs that we saw, based on whatever the users requested. So we have the REST interface itself is pluggable. So technically, users can add their own plugins to provide their own REST endpoints. We have a flexible events framework internally to allow, say, communication of asynchronous communication of events internally, so that plugins can be notified of what's happening in other parts of Gluster without explicit connections between the two modules. And one of the biggest changes is that instead of trying to store and synchronize our cluster information manually, we are now depending on etcd. So etcd to provide a centralized store for us. So in Gluster D1, we used to store information as text files on each and every peer in the cluster, on each and every server in the cluster. And the way we did our transactions, the way we did our operations was all specifically tuned to keep all of these stores in all the nodes in the cluster in sync. But that worked well when your clusters were small, but as they grew to larger sizes, say 50s to 100s and beyond, that was really bad and it didn't scale really well because it sort of worked like a mesh system where all your operations reached all nodes had to persist something. It was hard, and if something did fail, if we had a split brain, it was sort of hard to recover from that. So in Gluster GD2, we are moving to use HCD to perform the replication of the data to keep the consistent cluster information. But we use HCD in such a way that Gluster users don't have to manage HCD. So Gluster has an internal HCD algorithm to automatically set up an HCD cluster and manage it. So by default, it creates a 3-node HCD cluster automatically whenever you do a peer probe. So Gluster users don't have to do that, and Gluster uses that cluster. And Gluster automatically will take care of promoting or adding new peers to the new servers to the HCD cluster when needed. Say if one of the original HCD servers did go down, Gluster will automatically bring up another server to the cluster, so that you always have the requisite number of HCD servers running. Yeah. And so this is what GD2 is like right now. So this is like the basics of GD2. In 4.0, Gluster GD2 will remain a technology preview version. We are not calling it. We're not going to force everyone to move to it right away. So in 4.0, we'll have most of the Gluster D1 commands implemented, or original Gluster CLI commands implemented. There'll be some commands missing, particularly with related to say tiering, related to the internal Gluster NFS servers, and some integration pieces that we had with Samba and Ganesha and others. So they will be missing in 4.0. There will be a preliminary support for automatic volume creation. So we are pulling in some of the Hecate APIs to GlusterFS. So you'll be able to hopefully create a volume by just requesting for a volume name and a size. So you'll get a volume back from Gluster with that size that you asked for. And in 4.0, GD2 is not going to support migration from 3.x. So yeah, that's that. So users may be able to manually do the migrations by themselves if they want to, but they will not. We won't be having any sort of scripts or anything to help users migrate away in 4.0 itself. Beyond 4.0, with 4.1 and beyond, so in 4.1 is planned to be Gluster 4.1 is planned to be a long-term maintenance release. So by that time, we'll be stabilizing more. We'll have full documentation on all the commands that we support, on all the APIs, and the different workflows, management workflows that you can use them for. We will bring in support for migration from the older release. So at that point in time, we'll provide with scripts that will help users migrate data from the old Gluster store into HCD, into the HCD store. We'll also be doing things like centralizing logging. We'll have tracing frameworks implemented so that users can visualize the Gluster commands flowing, the Gluster management commands at least, how they're happening over the cluster. We'll also be improving upon our automatic volume management, and we'll be bringing in things like +1 scaling. +1 scaling is going to be a mainly a management feature. Yeah, and maybe do things like automatic cluster formation where you don't even need to do probes for cluster to form. So Gluster servers should be able to discover each other. And in addition to that, we'll be again bringing in more native APIs that help integrate Gluster with other projects and to provide a single API for different sorts of workflows. So you wouldn't need to run multiple Gluster commands to do a node replacement now. So it would just be a single API. So since I mentioned that GD1 is not compatible with GD2, there is going to be a specific upgrade path. So the upgrade path is going to be there. Okay, sorry. Okay, so we have a specific upgrade path. With the upgrade path, what we're trying to do is we want to avoid any file system downtime. That means that we want the file system layer to be always available. So any clients that have access to volumes that are running will retain their access continually throughout the upgrade process, and they can continue writing, reading from the volumes as the upgrade progresses. One caveat is that this only applies to volumes that are redundant, as in purely distributed volumes, distributed storage won't get this capabilities, but volumes that are replicated or erasure coded can do this. So to do this, what we will be doing is we'll be shipping both the new Gluster and the old Gluster in Gluster 4.0 and Gluster 4.1. So what this means is that users will be able to upgrade from Gluster 3.13 right now to Gluster 4.0 or Gluster 4.1 using the old Gluster. So you'll be able to do a live rolling upgrade. So these are this is a documented procedure already, and then we'll provide you with ways to do a migration from the old Gluster to new Gluster. So that yeah. So I'll describe the steps in the next slide. So right now we plan to ship the old Gluster in Gluster 4.0 and Gluster 4.1. We currently plan to remove Gluster 1, the old Gluster from Gluster 4.2. During this time, Gluster 1 will not receive any feature updates. So it's basically essentially what we have right now in 3.13. So yeah, these are the expected steps for upgrades. So as I mentioned, initially users will need to perform a rolling upgrade from Gluster 3.x to 4.0 using Gluster 1. So the steps are as described here. So you install the new packages on each server, one after the other. So install it on one server, restart the GlusterFS process on that server, do a heal of the volume so that any data that was returned to volumes during the upgrade of that node get replicated properly. And once the heal is completed, you move on to the next node. So by doing this, you always have access, clients always have access to the data on the volumes during the upgrade process. So you move from 3.x release to the 4.0 release without any downtime for clients. After this upgrade, we will do the move to Gluster 2. So we then expect we would be killing Gluster 1. So this just kills the management layer. Your file system still is alive. Clients will still be able to access them. But at this point in time, when Gluster 1 is killed, there are no management daemons running anywhere. New clients won't be able to access it, access GlusterFS volumes. But anything already connected, they will still have access. So once Gluster is killed, everywhere in the trusted storage pool, we'd go ahead and start the new Gluster 2. And once Gluster 2 starts, we'll do the migration into Gluster 2. So during the migration, we would form the new cluster using Gluster 2. Then we'll have scripts to import data from the old Gluster store into etcd. And once the data is imported, Gluster 2 should automatically just pick up the running file system daemons and begin to manage them. And migration is complete, or upgrade is complete without downtime for clients. And yeah, that's it. So any questions, you can ask me now. We also have, thank you. Yeah. Yeah, so the question is, do we embed etcd in GD2? Yes, we do. So we have our own etcd embedded, but if users want to, they can actually connect to an running etcd service. So that's intended for use cases where Gluster is run, say, in containers, in Kubernetes, or OpenShift, where they already have etcd running and managed. So, but the internal etcd is managed by Gluster 2. People may be able to access the Gluster 2 instance of etcd, but we're still not sure if we want to provide that access directly. Yeah. Yeah.
Do you have a timeline for 4.1?
4.1 is planned for 3 months from 4.0, so GlusterFS follows a 3-month release cycle. So yeah, end of February, March. Okay, so the question was, do we have a timeline for 4.0, 4.1? So yeah, Gluster follows a 3-month release cycle. So 4.1 is planned for end of February. So March, April, May, end of May, early June should be 4.1. Yeah.
How far is the Kubernetes integration coming along as a consumer?
Sorry, as a consumer.
Yeah, to use the volume of the new APIs you have.
Yeah. So okay, the question is, how far is the Kubernetes integration with GD2? Not much right now, so we are just trying to implement the Hageti APIs directly, but we have additional projects in the GlusterFS community that provide you with Kubernetes providers, I think they're called, stuff like that. Right now, those providers speak the Hageti API, but since we are basically moving that API as it is to GlusterD2, the similar case, they'll be able to work with GlusterD2 directly once it becomes stable. Any more questions? Yeah.
What's the impact between the old clients running against the new 4.1 or 4.0 environments?
So the old clients, okay, the question is, what's the impact of running old clients against the new 4.1 cluster, 4.0 cluster? Yeah, right. So the old clients, since the old protocol still remains, the old clients should have the lower performance technically. The clients running the new protocol, because of the improvements we did to the on-wire encoding, they should have slightly better performance. But they should still run. Yeah?
For your proxy implementation of the GF API, do you see any performance impact? Go another step and
Okay, the question is there a performance impact for the GF proxy implementation, right? So yes, because there'll be 2 hops, but depending on where the proxy daemon is running, it sort of makes it simpler. So if the proxy daemon is within the trusted storage pool itself, so clients just have to do one request to the proxy daemon instead of like sending out multiple requests to multiple servers in the pool for application and all. So for some use cases, there'll be a bigger impact. For some, not so much, I guess. So I don't know much about that GF proxy, how it's going to work, but we have some of the developers around. We have a stand in the K building, right? You can visit us there. I guess we have a developer around who can answer that question. I don't know particularly. Does Niels know?
Yeah, sure. Yeah, we spoke a little bit about it, but we can talk more.
Okay.
If you need more details. Yeah.
Okay. Any more questions? Yeah.
Can you say a few words about your experience of moving to Golang
Mhm.
on the Gluster D side?
So you want a few words from me on my experience of moving to Golang?
Yes, on that specific one.
Yeah, so one of the things was that moving to Golang allowed us to concentrate more on the challenges that we had, like designing the frameworks and concentrating on designing the frameworks, designing the pluggability, keeping it modular part, instead of worrying more about all the C-specific problems that we had, like memory allocations, doing all of that probably. So we could concentrate more on the logic, and Go itself has built-in support for lots of things like styling and all the tools for CI and all. It's better than C. So it helped us move to GD2 much faster than what it would be if we had done it in C again. So that's all I can say. Yeah? Any more questions? Nope. So thanks everyone. So